Rodney S. Ruoff is an American physical chemist and nanoscience researcher. He is one of the world experts on carbon materials including carbon nanostructures such as fullerenes, nanotubes, graphene, diamond, and has had pioneering discoveries on such materials and others. Ruoff received his B.S. in chemistry from the University of Texas at Austin and his Ph.D. in chemical physics at the University of Illinois-Urbana. After a Fulbright Fellowship at the MPI FU Stroemungsforschung in Goettingen, Germany and postdoctoral work at the IBM T. Watson Research Center, Ruoff became a staff scientist in the molecular physics laboratory at SRI International.He is currently UNIST Distinguished Professor at the Ulsan National Institute of Science and Technology, and the director of the Center for Multidimensional Carbon Materials, an institute for basic science center located at UNIST. Research. Ruoff and his research groups have made seminal contributions to developing new synthesis techniques and improving our understanding of properties of novel materials including nanostructures and 2D materials, especially novel carbon materials. Some examples of pioneering studies, among others, include of the mechanics of C60, and of nanotubes, including pull-out of inner shell with respect to outer shell of the nanotube, and of a connection between mechanical deformation and structure on the one hand, and chemical reactivity on the other. Of solubility phenomena of fullerenes, nanotubes, and graphene. Of carbon-encapsulated metal nanoparticles. Of patterned graphite and thus micromechanically exfoliated graphene-like flakes. Of scaled growth of graphene on copper and copper-nickel foils. Of isotopically labeled graphites and graphene. Of graphene oxide and reduced graphene oxide and composites and paper-like films composed of them. Of the use of chemically modified graphene and graphite foam for electrode materials in electrical energy storage. Of graphene as a support film for biological TEM. Of graphene as a protective coating against oxidation. Ruoff provided some personal perspectives on graphene and new carbon materials on the Horizon unregistered trademark in 2012. As a graduate student at the University of Illinois-Urbana, Ruoff and colleagues published seminal papers on the structure of weakly bound clusters formed in supersonic jets, and of relaxation processes in supersonic jets. His predictions with A.L. Ruoff about the mechanical response of fullerite under high pressure, and his work with colleagues on the unique solvation phenomena of C60 in various solvent systems, and of synthesis and structural characterization of supergent fullerenes containing single crystal metal encapsulates unregistered trademark, have demonstrated to the scientific community the novel properties of closed-shell carbon structures. He also co-developed a new in situ mechanical testing device for measuring the tensile response of bundles of SWCNTs and individual MWCNTs inside of a scanning electron microscope. This work has yielded important insights into the mechanics and tribology of these systems, and suggested the possibility of very low friction linear bearings. Similarly, Ruoff and collaborators were the first to use solubility parameters to rationalize the solubility of fullerenes, of single-walled nanotubes, and of chemically modified graphenes. Furthermore, Ruoff is credited with first creating graphene by lithographic patterning to make single-crystal graphite micropillars. He and his team achieved thereby single-crystal multi-layer graphene platelets. More recently, Ruoff and collaborators have demonstrated synthesis of large-area monolayer graphene on copper foil by chemical vapor deposition, for which relatively high carrier mobilities have been obtained, and subsequently have used isotopic labeling and micro-Raman mapping to map grains and grain boundaries in such atom-thick layers and to elucidate growth mechanisms, and studied their performance as transparent conductive electrodes. Ruoff and his collaborators have also made a series of advances in novel composite systems comprising chemically modified graphene platelets. Ruoff and his team were the first to use graphene as electrodes of electrochemical capacitors, reporting on graphene supercapacitors in 2008. Recently, Ruoff and his group reported on a new carbon, potentially having regions of a Euro-negative curvature carbon a Euro-1 registered trademark with a remarkably high specific surface area of 3100 m², Ga1, and atom-thick carbon sp2 bonded walls that define pores varying in diameter from about 0.6 to 5 nanometers. They showed that this type of porous carbon works very well as an electrode material for double-layer supercapacitors, a very exciting advance. Rod has a Hirsch factor of 101. Positions: UNIST Distinguished Professor of Chemistry and Materials Science and Engineering, Ulsan National Institute of Science and Technology, Cockrell Family Regents Chair Professor, Mechanical Engineering, the University of Texas at Austin, Professor and John Evans Professor, Mechanical Engineering, Northwestern University, Associate Professor, Physics, Washington University, Staff Scientist, Molecular Physics Laboratory, SRI International, Postdoctoral Researcher, IBM Thomas J. Watson Research Center, Postdoctoral Researcher Fulbright Fellow, Max Planck Institute für Stroemungsforschung. Awards and Fellowships: Turnbull Award, Materials Research Society, Materials Research Society Fellow, American Association for the Advancement of Science Fellow, American Physical Society Fellow, Distinguished Chair Visiting Professor, Sungkyunkwan University Advanced Institute of Science and Technology, Fulbright Fellow. External links: Mrs. F. 14 Turnbull Lecture given by Professor Ruoff, www.youtube.com. Retrieved February 17, 2015. Center for Multidimensional Carbon Materials cmcm.ibs.re.kr. Retrieved February 13, 2015. Professor Rodney Ruoff cmcm.ibs.re.kr. Retrieved February 13, 2015. References